All right, let's talk about something you probably use every single day but never really think about: the toilet. Now, it seems pretty simple, right? But what if I told you its reliability, that perfect flush, actually depends on a food product? Yep, you heard me. We're about to dive into the truly weird connection between your bathroom and the humble soybean. I mean, think about it. If you're an engineer, how do you guarantee a toilet is going to work flawlessly before it's even in someone's house? You can't just cross your fingers and hope for the best. You need a solid, repeatable test. But what on earth do you use to simulate, its main job? Well, as it turns out, the original answer was anything but scientific. Can you believe this? The industry standard literally went from chucking sponges into the bowl to using a specially engineered soybean paste. Now, this wasn't some tiny adjustment. It was a complete overhaul of how they did things. So how in the world did we get from a cleaning supply to a bean paste? Well, that's the story we're flushing out today. Okay, so to really appreciate the genius of the soybean solution, we've got to look back at why the old way was just so bad. It was completely unrealistic, and frankly, it just wasn't getting the job done. The whole issue really boils down to what we can call the sponge problem. Now, I get it. On the surface, it kind of makes sense. Sponges are absorbent, they can test if water is draining, but in the real world, they failed completely to mimic what a toilet actually has to handle. And that led to some pretty serious design flaws. Just think about it for a second. Sponges are totally unrealistic. They float, they have a completely different density, and they behave nothing like organic matter. So the tests weren't simulating real-world use at all. It was kind of like testing a car's crash safety by tossing a beach ball at it. Sure, you're doing a test, but it's not telling you anything you actually need to know. So, yeah, the industry was desperate for a change. It needed a much better benchmark, something that could give engineers real, useful data. And luckily, the solution came from a couple of innovators who decided to just tackle this problem head-on. So, let's meet Bill and John. These two engineers took one look at the whole sponge method and saw it for what it was: totally unscientific and super unreliable. They just knew there had to be a better, more realistic way to guarantee a toilet would work when it mattered most. What they were trying to create is something called a functional model. It's basically a substitute that acts just like the real thing you're trying to test. They needed a material that behaved like human waste, but, without the obvious biohazard and consistency issues. That's a pretty tall order. And this is where they had their big breakthrough. After looking at all sorts of different materials, they finally landed on the perfect organic substitute: soybean paste. It was safe, it was consistent, and, crucially, they could engineer it to have the exact properties they needed for a super reliable test. Now, this amazing innovation wasn't just about a new material. It led to a whole new system for certifying toilets. And this system became known as the Maximum Performance Testing Protocol, or just the MAP test for short. So the new MAP standard set a really clear benchmark. To even be considered effective, a low-flow toilet had to prove it could clear at least 250 grams of this soybean paste in one flush. That was the new bare minimum to get on the market. But the test also helps find the absolute best of the best. The top performance benchmark for a really high-end toilet is a whopping 1,000 grams. That's a full kilogram. If a toilet can handle that, well, it can pretty much handle anything. The whole process is actually pretty elegant and simple. You use the standardized soybean paste, you measure exactly how much of it gets cleared out in a single flush, and then you certify the toilet's performance against those benchmarks, from that 250-gram minimum all the way up to that elite 1,000-gram tier. So, okay, a couple of engineers, a bunch of sponges, and a whole lot of soybean paste. It's a fun story, but why does any of this actually matter to you in your own home? Well, this quote from the source material really sums it up perfectly. This wasn't just some weird test they came up with. The creation of this engineered paste fundamentally changed how we design sanitation systems. It created a standard that forced companies to build way better, more efficient toilets. And really, that's the big takeaway here. The soybean standard is your guarantee. It means the toilet you buy has been put through its paces against a really tough, realistic benchmark. It gives you reliability and peace of mind, all thanks to a simple but brilliant substitute. It really makes you wonder, doesn't it? What other normal, everyday object in your house is secretly backed by some bizarre and brilliant engineering standard we don't even know about? Thanks for joining us for this explainer.
All right, let's lift the lid on something you use every single day but probably never ever think about, your toilet. Get ready, because we are about to dive into the surprisingly brilliant engineering story behind getting that perfect, one-and-done flush. So let's just jump right in with a really weird question. Why on earth would a highly trained engineer spend their day flushing hundreds of grams of soybean paste down a toilet? I know, it sounds absolutely bizarre, but you have to stick with me because the answer is honestly fascinating.
So yeah, that 350-gram question, it's not just some random weird fact. It's actually the key to a whole story of clever innovation that was born out of some pretty serious frustration for a lot of people. At the end of the day, it really all boils down to a single goal that I think we can all get behind: creating a modern, water-saving toilet that actually works, on the first try. No clogs, no needing the plunger, no flushing twice. Just simple, quiet reliability.
Now, to really get why soybean paste was such a game changer, we kind of have to go back in time a bit. The whole problem really started with that first generation of low-flow toilets and the completely flawed way they were being tested.
I mean, you can see the total disconnect right here. For years, the industry standard for testing a toilet's power was flushing, sponges, and little plastic balls. It's a method that had almost nothing to do with what a toilet is actually for.
And this quote just nails it. The old tests weren't realistic at all. Manufacturers were passing the sponge test with flying colors, sure, but they weren't testing for reality. And this led to a whole generation of low-flow toilets that, yeah, they saved water, but they clogged all the time, driving millions of us completely crazy. And this is where our heroes enter the picture. Two engineers, Bill and John. They looked at this whole mess and just knew there had to be a better, more scientific, and just more realistic way to measure a toilet's actual flushing power. And they didn't just wing it. They followed this really clear, methodical process. First, they pointed out exactly why the old sponge tests were basically useless. Then, they did the hard science, researching the actual physical properties of, well, From there, they could develop a stand-in that behaved the same way. And this part is absolutely crucial. They created a standardized recipe, so every single test on every toilet would be perfectly fair and consistent.
And here it is, their brilliant invention, soybean paste media. Now, this isn't just some paste you grab off a shelf. It's a carefully engineered, totally non-toxic substance. Its density, its consistency, all of it is designed to be the perfect scientific proxy for the real deal.
So, with this new super realistic testing media, the MAP flush test was born. That's MAP for maximum performance. And it didn't take long for it to completely revolutionize the entire industry and become the new gold standard. So how does it work? Well, the test itself is actually beautifully simple. The testers use these little standardized 50-gram tubes of the soybean paste. They add them to the bowl, one after another, and flush, increasing the load until the toilet finally fails. It's how they can measure a toilet's true, raw power with incredible precision. So, what's a good score? Well, the best, most powerful toilets on the market today can flush a mind-boggling 1,000 grams of this stuff. That's a full kilogram. It is a massive leap forward in flushing power. And this little chart here really helps make sense of those numbers. A toilet that can handle 250 to 400 grams? That's passable, maybe fine for a guest bathroom that doesn't see a lot of traffic. But for your main bathroom, you're going to want to look for something in that recommended range. And if you want total, absolute, clog-free peace of mind, well, you aim for the top, that highly recommended 1,000-gram score. Okay, so cool engineering story, right? But what does it all really mean for you? Well, the easiest way to think about it is that the MAP score is basically a report card for one of the most important fixtures in your entire house. Because for you, the MAP score means you finally have a trustworthy, totally unbiased way to shop for a toilet. It means you can finally say goodbye to the frustration of clogs and having to flush twice. And maybe best of all, it gives you real confidence that the modern, water-efficient toilet you're buying actually has the power to get the job done right. The first time.
Which brings us all the way back to the beginning. That bizarre question about flushing soybean paste? Turns out it's not bizarre at all. It is the very reason you can now walk into a store, look for a simple number, and buy a toilet knowing, with total confidence, that it's been tested for the real world.
It just goes to show you there's an amazing amount of thought that goes into the things we totally take for granted. It really makes you wonder, doesn't it? What other everyday objects are you using right now that are hiding their own incredible engineering story, just waiting to be told?